Hello everyone, welcome to this tutorial on digital computer fundamentals. And in today's lecture, let us discuss about binary number system. The binary number system is simply another way to count. It is less complicated than the decimal number system because it is composed of only two digits. It may seem more difficult at first because it is unfamiliar to you. Just as the decimal system with its 10 digit is a base of 10 system, the binary system with its 2 digit is a base of 2 system. The two binary digits are 0 and 1. And the position of the 1 or 0 in a binary number indicates its weight value within the number. Just as the position of decimal digit determines the magnitude of that digit, we have discussed this in the previous lecture. The weight of each successively higher position in a binary number is an increasing power of 2. Now, to say that, when I say imagine I have a binary number called 10, this is a 2 to the power 0 weight and there's a 2 to the power 1 weight, and if there is another digit, it is a 2 to the power 2 weight. From right, when you move towards left, it is in the increasing power of 2. Now how do we count in binary system? If you have one bit, you can count as 0 and 1, but beyond 0 and 1 I need to count 2, 3, etc. So I need an extra bit. Okay, so I have 0, 0 is representing 0, 0, 1 represent 1, and 1, 0 represents a 2, 1, 1 represents a 3. Now, when we are learning to count in binary, let's recall how did we count in decimal. We started from 0 and counted up to 9. And then we did not have any digits beyond 9 because decimal number system consists of digits from 0 to 9. So to count beyond 9, what did we do? We then started another position to the left and continue counting 1, 0 through 9, 9. Again, at this point, we have exhausted all the two digit combination. So a third digit is added to count from 100 through 999. So we can compare it in a similar way in binary. So at the beginning, we count 0 and 1. At this point, we have used both the digits. That is, we have used both 0 and 1 here. So we cannot stop here. We need to count further. So to begin counting, we will take a combination of two digits. So we could count till 3. Now again we have exhausted. So we'll have to take 3 digits. So now we have taken 3 digits. We could count till 4, 5, 6, 7. Again we have exhausted our digit. So to count beyond 7, we'll have to take 4 digits. And this procedure goes on. Now you must be wondering, how do we recall these numbers, like to say that 0 is represented as 0000 in 4 bits, 1 is represented as 0001 in 4 bits. There is an easy way to remember how to write a binary sequence. The rightmost column in the binary number begins with 0 and alternates each bit. So you can see that the rightmost column, it begins with 0 and it alternates. That is 0, 1, again 0, 1, 0, 1, 0, 1. There's an alternative sequence. If you see the next column, begins with two zeros and alternates every 2 bit. So it begins with two zeros and then it alternates every 2 bit. Next 2 bits are 0, next 2 bits are 1, again next 2 bits are 0, next 2 bits are 1, and goes on. If you see the next column, it begins with 4 zeros and alternate every after 4 bits. So if you see 1, 2, 3, 4, 4 zeros, and then you have 1, 2, 3, 4 ones, again 4 zeros, again 4 ones. If you see the next column, it begins with 8 zeros and alternates after every 8 bits. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Next you will have 8 ones. 1, 2, 3, 4, 5, 6, 7, 8 ones. After this you will have again 8 zeros if you are considering the next sequence of bits. So if you can see this, it is see here 0, 1, 0, 1. Alternate every, so let me say it is 4 bits. Alternate every 1 bit is getting alternated. That is 2 to the power 0. Because we have seen that the weight of it is 2 to the power 0. 2 to the power 0 is equal to 1. So every 1 bit it alternates. Next bit alternates at every 2 bits. 2 to the power 1 is nothing but 2. So every 2 bits it alternates. Next is 2 to the power of 2. That is every 4 bits it alternates. Next is 2 to the power of 3. That is every 8 bit it alternates. If you have a fifth bit, After what bit it will alternate? 2 to the power of 4. That is, after every 16 bits, it will begin with a 0. After 16 bit, it alternates to 1. And again, next again, you will have 0. So we can say that. So now if you can see this, when I have 1 bit, I will have 2 to the power of 1 combinations, that is 2 combinations, 1 combination and 2 combination. And how many bits I can count? How many digits I can count? 2 to the power minus 1, that is 2 minus 1, 1. I can count till 1 because 0 I am ignoring, that is why I am reducing 1 from this. So when I have 2 bits, 2 to the power of 2 combinations I can get, that is 4 combinations. See this, 1, 2, 3, 4 combinations I'll get. But till what number I can count? 2 to the power 2 minus 1. Minus 1 because I have a 0 here. 2 to the power minus 1 is 4 minus 1, which is equal to 3. So I can count till 3. Hope you can see this. Now if you have 3 bits, how many combinations I can have? 2 to the power 3 combinations, that is 2 into 2 into 2, 4 into 2 is 8, 8 combinations. So I'll have 1, 2, 3, 4, 5, 6, 7, 8 combinations I can have. But till what number I can count? 2 to the power of 3 minus 1 till 7. 8 minus 1 is 7. Till 7 I can count. Similarly, when you have 4 bits, you have 2 to the power of 4, 16 combinations, and I can count till 2 to the power of minus 1, which is equal to 15. Right? Okay. So depending on till what number you need to count or need to represent, you will decide the number of bits that is required. So to conclude, we can say with 2 bits we can count from 0 to 3, that is 2 to the power of 2 minus 1, which is equal to 4 minus 1, 3. With 4 bits we can count from 0 to 15. So if we can generalize it by saying with n bits we can count till 2 to the power of n minus 1. So n can take any value. So if you want your system to count, if you are building a system and it should represent numbers, this much numbers that you decide earlier, then you can decide what is the number of bits that your system should be able to uh, hold. Okay, so that's all for counting in binary. Yeah, if you like the video, kindly subscribe to the channel. We will come up with a new lecture series on uh, binary arithmetic in the next video. Okay, thank you so much.